Hello and welcome to Cannon County High School Algebra 2. Let's talk about degrees and radians. This is a new topic, one we haven't talked about before. And you already know how to measure angles using degrees. And today you're going to learn how to use a new measure called radians. And you might be thinking to yourself, well, why in the world would I want to have a new way of measuring angles, Mr. File, because degrees work just fine. Here's the way you want to think about that. Let's say you're a mechanic and you're working on cars. You have to understand both the metric system and you have to be able to use standard English units, because let's say you're working on a Toyota, you need to know how to use the metric system. If you're working on a Chevy, you need to know how to use standard units. And so it's good to know both. They both measure the same thing, they just do it in a different way. Well, the same thing is true with degrees and radians. Radians are used a lot in trigonometry. And radian measure sometimes makes trigonometric problems much easier. So you have to be able to understand both degrees and radians. So that's what we're going to talk about today. So, Mr. Lyon, I'm going to have to move you again, I'm sorry. Okay. Let's talk about that. First, you need to know what standard position means. The standard position of an angle. Okay? Let me see if I can zoom in just a hair so you can see that a little better. You probably remember this from geometry, but the standard position of an angle has the vertex at the origin, right here, and then the one ray is on the x-axis, like this, and that is called the initial ray. And then the terminal ray comes off of that, so it goes in a counterclockwise direction, and this one is called the terminal ray. And this is the angle right here. Now, the higher you go in math, the more Greek letters that you use. We're going to be using a lot of times Greek letters for the angles. And theta, which is kind of like an oval type circle with a line through the middle of it, theta, looks like this. Theta is an angle that we're going to use for that. So, initial ray along the x-axis, terminal ray, and the angle between is called theta. All right, let's talk about what a unit circle is. This is, again, should be review from geometry, but a unit circle has a radius of 1. So you can see this perfectly drawn circle that I have here. I failed art class, can you tell? Anyway, it has a radius of 1. Arc length is part of the circumference. You learned that the circumference of a circle is 2 times pi times the radius. Well, the arc length is the distance from point A to point B along the circle. And the way that you figure out arc length is you take the entire circumference, 2 pi r, and then you multiply that by whatever fraction of the circle this is. So that would be theta divided by 360. So you got 2 pi r times whatever the degree measure of theta is divided by 360, because that would be the piece of the pie that we're talking about here. But this is just that distance right there, from there to there, okay? So let's try that with an angle measure, okay? Let's try it with 30 degrees, for instance. Let's say theta is 30 degrees. So that means that the arc length is going to be 2 times pi times the radius, which we just said was 1, times 30, which is theta, divided by 360. Okay? And what we want to do is we want to figure out what that is in terms of pi. That means pi is going to be in the answer. That means when you figure this out on your calculator, you just leave pi in the answer. Don't put pi in the calculation. And you have a calculator, right? Because I told everybody to download the calculator app on their iPhone. This is an iPad and it's on here. Just make it bigger so you can see it a little bit. But when we calculate this, we're not going to actually type in the pi. So we're going to take 2 times 1, which is the radius. Notice I'm not putting the pi in there, times 30 divided by 360. And then since I want this to be a fraction, remember I go to math, and the first choice is fraction, so I hit enter, and then I hit enter again, and it says that the answer is 1/6. So use your Calculate 84 app on your phone to figure that out. But that means the answer is 1/6. But since I didn't multiply by pi, that would be 1/6 times pi, which is pi over 6. And that's the answer. Okay? That's what we call radian measure. It's arc length divided by radius. And in a unit circle, the radius is always 1. So that's pi over 6. Okay? So that's pi over 6 radians. Pi is usually in the answer on radians. Not always, but most of the time it is. Let's try some other angles. Let's try 90 degrees. So for 90 degrees, that's going to be 2 times pi times 1, which is the radius, times 90 divided by 360. And if you think about it, this is what the circle would look like. Here's the initial ray. Here's 90 degrees. So theta in this case is that angle right there. So that's 1/4 of the circle. So that's 90 degrees out of the total 360 degrees of the circle. So again, you should be able to do this in your head, but let's just do it this way. 2 times 1, well, I'm not even going to multiply by 1 this time because we know what that's going to do, times 90 divided by 360, turn that into a fraction. Oh, I typed 0.9, I'm sorry. 2 times 90 divided by 360, and it gives us, if I turn that into a fraction, a half. And so that means that the answer is, for 90 degrees, it's pi over 2. Because remember, we didn't multiply by pi. This is in terms of pi. This is how many radians that's equal to. Let's try another one, 45 degrees. What does that look like? Well, again, initial ray is on the x-axis, terminal ray right here. Now we're talking theta. Now again, you know that's like 1/8 of a slice of the pizza. So it's like you're taking 1/8 of the circumference. So again, that's going to be 2 times pi. I'm going to forget the 1 this time. And that's 45 divided by 360. So that's 2 times 45 divided by 360. And that's 1/4. So what's 1/4 times pi? It's pi over 4. Pi over 4 radians. Now these next two are important because these are, well, actually before we get to that, let's talk about this. Negative 60 degrees. Negative 60 degrees. Well, how is that possible? Well, that just means that instead of going counterclockwise, you start with your initial ray right here. Instead of going counterclockwise, now you go clockwise 60 degrees. So that's like a negative 60 degrees right there. So theta in this case starts at the x-axis and goes clockwise. So this time theta, it doesn't matter, it just means our answer is going to be negative. So that means we're going to take 2 pi times negative 60 over 360. So to keep it in terms of pi, we're just going to take 2 times negative 60 divided by 360, math, enter, enter, negative 1/3. So that means it's negative pi over 3. So you can get negative answers. That just means you're going clockwise instead of counterclockwise. Okay? All right, now, full circle. Well, now let's think about this. A full circle is 360 degrees. That's 2 pi. We don't even need the calculator for this one because 360 divided by 360 is 1. So a full circle is 2 pi radians. And that means that a half circle, 2 pi times 180 divided by 360, a half circle is going to be pi. So 180 degrees is equal to pi radians. That is really important for you to know, because that is the conversion that we're going to use to convert degrees into radians and radians back into degrees. Okay? So let's do that now. Let's do some conversions and see what that looks like. Since pi and 180 are the same, we're going to multiply by either pi over 180 to convert from degrees to radians, or we're going to multiply by 180 over pi to convert from radians to degrees. Because since pi and 180 are equal to each other, pi over 180 and 180 over pi are equal to what? 1, right? So whether it's pi over 180 or 180 over pi, it doesn't matter. It's equal to 1. And what happens when you multiply something by 1? You're not changing what it's equal to. We're just changing how we're measuring it. Okay? So we want to do some conversions now. So let's do some. Convert to radians. When you're converting to radians, you're starting out with something in degrees. Here's 500 degrees. Now, is it possible to have something that's more than 360? Yeah, of course it is. So you start here. Here's my unit circle. If we have an angle that goes all the way around to here, that would be 360. 360 plus another 90, how much is that? Well, you just keep going until you get all the way over to 500 degrees. Those of you who are skateboarders know you can do a lot more than 360. You can do a 540 or a 720 and so on. So, of course, you can have angles that are more than 360. The way you do this is you just choose whether you're multiplying by radians over degrees or degrees over radians. Since we have degrees up here, that means we want degrees in the denominator. So you're going to multiply by 500 times pi over 180. What happens then, since you have degrees on top and degrees on bottom, they cancel out. And you're going to leave pi in your answer because most often pi is left in the answer for radians. So we really just need to figure out what's 500 divided by 180 as a fraction. So let's do that. 500 divided by 180 as a fraction is 25 over 9. So that means my answer is 25 pi over 9. 25 pi over 9 radians. It's that simple. That's the answer. 500 degrees is the same as 25 pi over 9. Let's try negative 390. Do the same thing. Times pi over 180. Leave pi in the answer. So we're going to take 390, or negative 390, divided by 180. Negative 390 divided by 180. I want a fraction. And it says that that's negative 13 over 6. So I get negative 13 pi over 6. Let's try one more like that. 150 degrees. I think you've got it by now. You just multiply by pi over 180. Pi is going to be in the answer. You probably don't even need a calculator to do this one, but 150 divided by 180, that's kind of like 15 divided by 18. And you get 5/6. So that means the answer is going to be 5 pi over 6. Okay, so there we're converting from degrees into radians. Now let's do the opposite. Let's convert 2 degrees from radians. Pi over 10. Well, instead of multiplying by pi over 180, now this time we want the pi's to cancel out because we're trying to turn this into degrees. So this time you put pi on the bottom and 180 on top. Okay, that way the radians, the pi's, cancel out. And you're just left with 180 divided by 10. Well, I don't even need a calculator for that. That's 18 degrees. So pi over 10 radians is equal to 18 degrees. We're just multiplying by 180 over pi instead of pi over 180. Let's try another one. 7 pi over 6, same thing. Multiply by 180 divided by pi. Pi's cancel out. This one's a little more complicated. 7/6 times 180. Let's see what that ends up being. 7 divided by 6 times 180. I don't even need to hit math, enter, enter to give me a fraction this time because I don't want it to be a fraction. I'm converting to degrees. Oops, I didn't multiply by 180, I multiplied by 10. Let me do that again. 7/6 times 180 equals 210. So that means that 7 pi over 6 is equal to 210 degrees. Okay? Last one, negative 14 pi over 15. Well, again, that's a negative angle. That just means it's going clockwise on the unit circle. But again, you multiply by 180 over pi. Pi's cancel out. Negative 14 over 15 times 180. Negative 14 over 15 times 180. And that comes out to a negative 168 degrees. So that means the answer is negative 168 degrees. So today, all we're doing is converting degrees into radians and radians into degrees. That's going to be important for you to know how to do. So what I'd like you to do now is go to IXL, let's see, I believe it is x.1, and do that. If we were in class, I would say you need to do that to an 80%. But again, remember, this is suggested practice. You don't have to do it if you don't want to. It's not going to be graded, but I would suggest that you go to IXL and do x.1, and you're basically going to be doing some problems like this. You're going to be converting to radians and converting to degrees. Okay? So, thanks for watching, and we'll talk to you tomorrow. Bye.